All right, let's keep it going, working on section 6, Lewis structures. This shows how many valence electrons are arranged among atoms in a molecule. The most important requirement is that atoms achieve noble gas electron configuration, also known as the octet rule or the duet rule if we're talking about hydrogen or helium. All right, so here we have noble gas configuration, okay, because this potassium lost an electron, and it now has noble gas configuration, all right? It is the same as argon. All right, here we have bromine, all right? It has a negative charge because it has gained an electron, and it has krypton configuration. It has reached its noble gas configuration. All right, it is happy. It has a full outer layer of electrons. Writing Lewis structures. Bonding pairs are shared between two atoms. Unshared pairs, lone pairs, are not shared and not involved in bonding. So here we have fluorine with 7 valence electrons, and it is sharing one of its electrons with the other fluorine over here to form an F2 molecule, so that each one has 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. And this fluorine over here has the same. 1, 2, 3, 4, 5, 6, 7, 8. Steps for writing Lewis structures. Sum the valence electrons from all the atoms. Use one pair of electrons to form a bond between each pair of bound atoms, and arrange the remaining electrons to satisfy the octet rule or the duet rule for hydrogen. So sum the valence electrons from all of the atoms. Use the periodic table. So we have 2 hydrogens, so 2 times 1 electron, plus 6 electrons from the oxygen, so we have a total of 8 electrons. Use a pair of electrons to form a bond between each pair of bound atoms. So here we have a pair of electrons, and here we have a pair of electrons. And then we indicate our pairs around oxygen. All right, here we have PBr3. All right, we do the exact same thing. We figure out how many electrons we have and how many are being shared among our atoms, and then we put our lone pairs around the remaining atoms. All right, so draw a Lewis structure for each of the following molecules. So H2, they're sharing one pair of electrons, so we have one line. All right, F2, one pair of electrons shared amongst 2 of them. HF, one pair of electrons being shared, and our lone pairs are around our fluorine. And then CH4, there are 4 pair of electrons being shared, one with each hydrogen, so that it looks like this. Now, some atoms can form more than one covalent bond. A single covalent bond is a bond in which one pair of electrons is shared by 2 atoms. A double bond is a covalent bond when 2 pairs of electrons are shared by 2 atoms, and a triple bond is a covalent bond in which 3 pairs of electrons are shared by 2 atoms. A single bond is represented by a single line, a double bond is represented by 2 lines, and a triple bond is represented by 3 lines. Resonance is when a molecule has more than one Lewis structure that can be drawn for the molecule. So NO3- can be drawn these 3 ways because it has one double bond with oxygen, but it can have it with each of the oxygen molecules. It can't have the triple bond with all of them at one time, but it can have resonance like this. There are some exceptions to the octet rule. Boron tends to form compounds in which the boron atom has fewer than 8 electrons around it, so it does not have a complete octet. All right, molecules containing odd numbers of electrons like NO and NO2- also do not follow the octet rule. So here we have Lewis structures for each of the following molecules. BF3, has 3 single bonds between the boron and the fluoride. CO2, the carbon has a double bond with each of the oxygen molecules. CCl4 has 4 single bonds, 1 single bond with each of the chlorine, and CN has a triple bond between the carbon and the nitrogen. Concept check, consider the following compounds. Which one exhibits resonance? All right, well, CO2 exhibits resonance. Another concept check. Which of the following supports why Lewis structures are not a completely accurate way to draw molecules? Well, A says we cannot say for certain where an electron is located, yet when drawing Lewis structures, we assume the electrons are right where we place them. That's true. B, when adding up the number of valence electrons for a molecule, it is possible to get an odd number, which would make it impossible to satisfy the octet rule for all atoms. True. C, both statements 1 and 2 above support why Lewis structures are not a completely accurate way to draw molecules. Or D, Lewis structures are the most accurate way to draw molecules. Well, answer C is correct. Okay, we don't know exactly where the electrons are located. We are just using our best guess, all right, for ease. All right, electrons have areas that they're more probable to be in, and we're just taking that probability and saying, hey, they're here. And there are some times that we would get an odd number, which would make it impossible to satisfy the octet rule. Moving on to section 8, molecular structure. All molecules have a three-dimensional arrangement of the atoms in the molecule. All right, so here we have a linear molecule where they're in a straight line. Here we have them where they're in a triagonal planar molecule. And then here we have a tetrahedral molecule where we have 4 of one type of atom bonded to one central atom. Here is a linear structure. The atoms are in a line. This is carbon dioxide. And there is a 180-degree angle between the oxygen and the other oxygen. Trigonal planar, atoms are in a triangle shape. All right, this is boron tetrafluoride. All right, there is a 120-degree angle between each of the fluoride ions. And here we have methane, which is a tetrahedral structure. All right, we have 4 sides, all right, carbon in the middle, hydrogens surrounding it, 4 hydrogens. And it looks like that's it, guys. If you have any questions, let me know.